So the mechanism that the Linux community has opted for in order to break up or limit root privilege is called Linux capabilities, and it is sort of a broader effort in the POSIX standardization effort, and so the Linux capabilities are derived from the POSIX design. So the basic idea is that instead of saying that root can do anything and everything on the system, you sort of identify the specific things that root is able to do that normal users cannot do, and then you you categorize each of those, and then you have a lot of many different capabilities, and then you can selectively enable some of the capabilities to each root process. And that way you are going to, if let's say a certain root process is compromised, it's not going to be able to do anything and everything on the system, but only the subset of things that it has capabilities for. So some examples are, cap chown, which basically means that this process is going to be able to change ownership of a file, right? Cap DAC override basically means that it's going to be able to override file permission settings, right? So before we said that root process by default, there is no check on the file permission, and that is the idea of overriding the permission setting on the file, right? So now we have a specific capability. So if a root process has this capability, that means these file permissions are not considered when determining whether this process should have access or not. On the other hand, if it doesn't have this capability, then the file permissions are going to be still enforced. Okay. Similarly, net bind service basically has to do with whether the process can bind to a socket number where the port number is less than 1024, right? And then setuid says whether the process can change its user ID, and whether it can load modules, whether it can ptrace. So all of those become individual capabilities, and so they can be given or taken away from specific processes. So we already talked about operating system capabilities or classical capabilities, which are a little bit different, right? Because in the case of classical capabilities, we said that it is like a ticket that combines the object and the access that you have on the object, right? But here, if you can, as you can see from these examples, these accesses or these capabilities don't pertain to any specific object, right? So for instance, if you say DAC override, then DAC override is something that, so DAC override is something that applies to all files. So it's across all objects. So in that sense, it's not like a classical capability, but it has some aspects, which is that these capabilities can be inherited from a process to its child, and they are maintained inside the kernel, somewhat similar to how the kernel maintains, say, file descriptor information and so on. So let's understand a little bit more about these POSIX capabilities. So when we were talking about the Linux permission mechanisms, we talked about the user IDs associated with the subject, and we said there are 3 user IDs called the effective, real, and saved user IDs. Somewhat similar, but not exactly the same. We have 3 types of capabilities associated with each subject, and they are effective, permitted, and inheritable, right? So effective, as in the case of effective user ID, effective capability is the capability that's used when permission checking is done, okay? Now, what is permitted? Permitted is a superset of effective. So it's kind of like the saved or real user ID, in the sense that it says, oh, this user really may have more capabilities than what they are using currently. And so the permitted basically says that they can it can be a superset of effective, and the process can say, okay, let me move some of the capabilities from the permitted set into the effective set so that I will have that capability. Similarly, it can it can relinquish some of the effective capabilities so that it can operate with less privileges. And then when it needs those capabilities, it can move them from permitted back into effective and then operate. So inheritable is a special subset, and basically there may be a situation where a particular process has a certain set of capabilities, but you may not want its children to have those capabilities. And in that case, you're not going to put those capabilities in the inheritable set, right? So the idea is that when a process forks and execs, or just forks, only at exec, right? So when a process execs, then at that point, only the inheritable capabilities will be passed down. The non-inheritable ones will be taken out of both the permitted and the effective sets. Okay. So in addition, you can add capabilities to executables, so that even if the current process does not have those capabilities, when this file is executed, then those new capabilities are added to that process. Okay, so this is kind of like a setuid mechanism, but being applied to capabilities. Okay, so that's the what I wanted to say about Linux capabilities. And in practice, once again, it's a new mechanism and is available, and similar to the general access control list mechanism that's available in Linux. It's there, but it's not very often used. It's fully supported. So if you are someone who's designing some piece of software, some privileged application, then you should think about using these capabilities and using the minimum set of capabilities, so that you are practicing this principle of least privilege for your application. So that's again, for applications that are written in future, they should use these capabilities in a good way to limit their privilege. But for many existing programs, they are still relying on this root privilege with every capability that's out there, and that's not good. But again, that's where we are, but these mechanisms, the POSIX capabilities, provide a roadmap for getting from here to a system design where you are more closely practicing this principle of least privilege.